Hello and welcome to the first of 4 vlogs in 4 days as part of the Alteryx and Tableau in Sports series. In these vlogs I'll be using Alteryx and Tableau to identify potential replacements for an outgoing player. My examples are going to be based on football, but you'll see how you can apply this to other sports and even other industries. Now I'm going to be using a real-world scenario in which I'll be making use of the predictive grouping tools in Alteryx and the visual analytics capabilities of Tableau to identify these potential replacement players. So let's get started. First, I want to take you on a little trip back in time with me. No, not that long ago. In fact, not long ago at all actually. Just back to 2010, when the Black Eyed Peas and Lady Gaga were top of the charts, and Toy Story 3 was the box office smash hit of that year. Bolton Wanderers were 7th in the English Premier League and through to the semi-final of the FA Cup. Now, the relative success of Bolton Wanderers during that 2010-11 season was largely put down to one man. That was this man. The baby-faced American Stuart Holden. Now, Stuart was considered by many, teammates, fans, pundits, opponents, to be the fulcrum of Bolton Wanderers, and was largely praised for his ability to break up play, to be in the right place at the right time, and also to see that decisive, insightful pass that would split defences. Now, sadly, in March 2011, Stuart Holden got injured in a challenge against Manchester United, which put him out for a long time. Following this, Stuart never fully recovered, and Bolton Wanderers subsequently declined to the depths of the Championship. Many put this decline down to this one key moment. Now, to say that one man and one moment can affect the fate of one club so much is perhaps a slight exaggeration, but there's no doubt that Stuart Holden has been considered by many as irreplaceable. So, in 2011 summer transfer window, what could Bolton Wanderers have done to fill the hole left by Stuart Holden? Can you replace the irreplaceable? So there are 3 key tools that we're going to be using in Alteryx across this mini vlog series. Find nearest neighbour, k-centroid cluster analysis, and firstly, the principal components tool. So I want to give a quick intro into principal component analysis to those who have never come across it before. Now, much of the data used in sport has multiple dimensions. However, we are only able to visualize relationships in 2 or 3 dimensions in standard charts. For instance, looking at the number of passes per match and a number of these that are successful on a standard XY graph. Now, principal component analysis allows us to somewhat compress, say, 3, 4, 5 or more dimensions in the data to a smaller number, allowing for the visualization of multiple relationships at the same time. Therefore, rather than just looking at the number of passes per match and the number of these that are successful, we can actually visualize a number of additional dimensions on top as well, such as the number of short passes, the number of key passes, or the number of through balls. There are some great resources on the web if you need to understand principal component analysis further. But for now, I'm going to get started on this first example. I'm going to be using 2 databases obtained from the Opta F24 XML files. If you're unsure how to parse these XML files, please see an earlier blog in the Alteryx for Sports series entitled Parsing Opta XML Files. The 2 databases that I'm using are the Events database and the Matches database from the 2010-2011 Premier League season. The Events database provides us with the most granular level of detail obtainable from the Opta F24 files. This is row by row, event by event data. The second database is the Matches database. Now this provides us with a more generic overview of the players competing in a match and the match details itself, such as the total time in the match, the time that a player played, the position that he played, whether he was substituted or not, and at what time. The Events database is what we're going to primarily be using throughout this workflow. However, there are just a couple of fields that I would like to use from the Matches database. They will be position name and the time played for each individual match for each player. First, I want to get the position name, so I'm going to use this join tool. We drag the join tool down onto our workflow. We then connect both of the databases to the left and the right inputs. we are going to join the databases based upon the match IDs and the player IDs. Then, from the selection box below, we are going to keep all of the left data fields, but we are only going to require one of the right data fields, which is the position name. I'm going to select all of the right inputs initially, and then I'm going to go to the options and select and deselect the highlighted fields. Then I'm going to find our position name and just reselect that one. So we have all of the left data fields and just one data field from the right input. This is where it became important to have the position names in the events database. This is because I'm going to use the filter tool, and I'm going to use a contains formula, and I only want players who have played central midfield. Because in our positions that could be right centre midfield, left centre midfield, defensive midfield, right defensive midfield, left defensive midfield, I'm going to use this formula. So any positions that contain defensive midfield or centre midfield will be included. And I just want the true output of this. Now I'm going to use the Summarise tool to obtain just the summarised data for certain key metrics. So rather than having the event by event data, I'm going to aggregate this up to be by individual player for these certain metrics. Now the metrics I'm going to be using were all attributes that were considered a strength of Stuart Holden, and because we are looking for players that are similar to Stuart Holden, these are going to be the key metrics that we look at throughout this workflow. Those metrics are ball recoveries in the middle third, interceptions and key passes. First of all, we group by our player ID and our player name, and then we aggregate up using sum, ball recoveries middle, interception and key pass. Another field that I want to add to my stream of data is the total time a player has played across the season, enabling me to standardise the metrics by minute or per 90 minutes. This field is stored in my matches database. So I'm going to add a Summarise tool and again group by player ID, and this time aggregate using the sum of the field called match seconds played. This will give me the total seconds played by each player in my dataset. I'm then going to use the Find Replace tool and connect my two data streams to the left and right inputs of this tool. My common field is player ID, so wherever the player IDs match, I'm going to append that player's match seconds played. I'm then going to add another filter tool in and only include players who've completed 90,000 seconds of game time or more. That's around 15 matches if you include injury time. In this next step, I want to start to standardise our metrics, and I'm going to do this by changing the metrics to per minute metrics. So, how many ball recoveries per minute, for instance. The first thing I need to do is remove any null values from my data. So if a player hadn't completed any key passes, the value will be nil. But what we actually want is a value of 0. We could use multiple is-null formulas in various formula tools to change nulls for each field into a 0. But instead we're going to make use of the multi-field tool in Alteryx. This tool enables us to carry out the same calculation on multiple fields. In this instance, our 4 key metrics. So I'm going to select these here. And I'm going to say if the value is null, then 0. If not, then use the value that's already in place. You will see I have used the field called current field. This means that an isNull calculation will be carried out on all of our selected fields. I'm now going to use the same tool to standardise the fields per minute. So I select my fields, and also I'm going to copy the outputs to new fields with the suffix of per min. And then I'm going to enter my formula using the current field we mentioned in the previous tool. I'm going to divide this by the total match seconds a player has played divided by 60 to make it per minute rather than per second. I'm now going to use the select tool to remove some of the fields we don't want and rename some of the other fields. Next, it's on to the final part, the principal component analysis. This tool is in the predictive grouping section, and I'm going to drag the tool onto my workflow and connect it. I'm going to select the 4 performance attributes we want to relate to, and then I have a couple of options here. The first one, regarding scaling the fields, is essentially normalizing the data. I can also decide how many principal components to display in my graphical output and the number of principal components to append to my data stream. In this case, I'm just going to use principal components 1 and 2. I also have some additional graphic outputs here on this next tab, but I'm going to leave these as default for now. If I now add browse tools to the end of my workflow and run the workflow, we can then start to explore our outputs, with our principal components 1 and 2 appended to our dataset, which can then be plotted on a graph as shown here. We will look more in depth in a later blog as to how to visually analyse and explore this data in Tableau, but in short, each number plotted represents a player. For instance, Stuart Holden is number 35. And those that are plotted nearby him, for instance number 8, 28, 20 and 64, are most similar in terms of the metrics we analysed in this workflow. This workflow we've created is going to form the base of this 4-part vlog series, and by Thursday we will have an insightful Tableau dashboard with multiple ways to find our replacement player for Stuart Holden. Thank you for joining me for part 1, and I look forward to seeing you for part 2 tomorrow.